For our second Core 1 coordinate geometry lesson, we're going to look at the equation of straight line graphs and gradients of straight line graphs. We're going to look at how you can find equations for lines from minimum information, like for instance the gradient and a point on the line, or 2 points on the line. And we're going to see how these linear equations link things like the gradient and the y-axis intercept. As we all know, we can write the equation of a straight line in the form y equals mx plus c, where m is the gradient of the line or its steepness, and c is the point where the line meets the y-axis, what we call the y-intercept. So for example, the line y equals 2x minus 1 has a gradient m of 2 and a y-intercept c of minus 1. In other words, it meets the y-axis at 0, minus 1. There we are, and that's what the line looks like. The coordinates of any point on the line will satisfy the equation of the line. So for example, if we substitute in x equals 4, we get y equals 2x minus 1, so y equals 2 times 4 minus 1, y equals 7. So we know that the point 4, 7 lies on the line. Okay, so we're going to start off finding the equation of a straight line when we know its gradient and the coordinates of a point on the line. Because we know m, we can find c by putting in our x and our y value, and then we can replace the m and the c as numbers and y and x into the equation. So for example, we know the gradient's 2 and we know that the line passes through minus 1, 3. So we use y equals 3, m equals 2, x equals minus 1. So in y equals mx plus c, when y is 3, x is minus 1, m is always 2. So to find c, we simply put those values in. We get 3 equals minus 2 plus c. Add 2 to both sides, we get c equals 5. We now put the 2 back in for the gradient, the 5 back in for the c, and we get y equals 2x plus 5 as the equation of the line, which looks like that. And you can see there the point minus 1, 3 marked clearly on it. If we don't know the gradient, we can find it using 2 points on the line. We need a formula for this. Well, let's have a little look at what a gradient's all about. The gradient is the steepness of the line. In other words, how much it goes up for any amount it goes across. So for this particular line here, it goes up 4 for every 2 it goes across. So the gradient is 4, how much it goes up, divided by how much it's gone across. 4 divided by 2, m equals 2. If we put in the coordinate pairs of the 2 points, we can see clearly there that our y value for this point minus our y value for the first point gives us the height, in other words the change in y value, and the change in x value is how much we go across, which again is our x value for the second point minus the x value for the first point, like so. Okay, let's think what that means in general terms. Well, again, like we did in the previous lesson, we call the first point x1, y1, and the second point x2, y2. So how much we go across is x2 minus x1. Well, this x value here minus the x value there. And how much we go up is the change in the y values. Y2 minus y1 is the y value here minus the y value here. And this gives us a general equation for finding the gradient. y2 minus y1 divided by x2 minus x1. We don't need a diagram, we can just do it straight from the points. So to find the gradient of a straight line joining the points 0, minus 1 and 2, 3, we simply call 0, minus 1, x1, y1 and 2, 3, x2, y2 and sub those values in to our equation. So our y2 is 3, our y1 is minus 1, our x2 is 2 and our x1 is 0. So plug them in and then we get m as 4 over 2, so m equals 2. To find the equation of a straight line given 2 points on the line, we can find the gradient using our formula. In this case, between the points, or the line that goes through the points 2, minus 3 and minus 1, 3, we can see that by putting in our y2 minus y1, x2 minus x1, we get a gradient of minus 2. In other words, the line goes down 2 for each one it goes across. We can now use that in y equals mx plus c. We have the gradient. We can use either point, doesn't matter which, as long as we're consistent and we use that x value with that y value, or that x value with that y value. So we're using minus 2 for our gradient, and then we'll use the first point, stick in the x and the y value to find c. We get c as 1, and then put the minus 2 as m and the 1 as c back in y equals mx plus c. And we get the line y equals minus 2x plus 1. So to summarise, the equation of a straight line can be written in the form y equals mx plus c, where m is the gradient and c is the intercept on the y-axis. And the gradient of a straight line can be worked out using the formula m equals y2 minus y1 divided by x2 minus x1, where x1, y1 and x2, y2 are points on the line. Okay, to finish off then, have a go at these two yourself. I'll show you the answers in a minute, so pause the presentation and have a go. Okay, so the first one, we're given the gradient, we're given a point, so we use y equals mx plus c, we stick our gradient of 2 in, we stick minus 1 in for y and 4 in for x, gives us a c value of minus 9. We then rewrite y equals mx plus c with our 2 in for m and minus 9 in for c. So we get y equals 2x minus 9. The next one, we work out the gradient first using our gradient formula. We get a gradient of minus 3. We put that in. We use either of the points. We use the first one again, minus 1, 2, to get our c value. And for this one, we get y equals minus 3x minus 1. Okay, if you're successful with those, or more or less successful, maybe I'll tolerate a slight error, then you should be fine for the lesson. Otherwise, you may need to go over the video again, or possibly look at this topic on My Maths, or have a look in the textbook.